So welcome back everyone. I am your host Shane Furs. This is the second instructional video for Soils for Plant Growth for Forestry 2505. Our first video covered looking at site factors, determining where our transect is going to be, deciding where to dig a soil pit, and covering mainly our soil forming factors. One thing I'd like to mention is when you locate where you want to dig a soil pit, which is what this video is going to cover, you first want to look at the vegetation that's surrounding your soil pit. So first thing you want to do is you want to find a site that you're relatively at least a meter away from any large tree. The last thing we want to do is be struck by a large root within our pit in which we can't dig through. We don't want to cut the roots if we don't have to, since they will damage the trees. So we find a nice open area to dig our soil pit. We don't want to dig our soil pit directly on the top of a mound or in a pit, just because it's going to alter the horizons we see. We want to be on kind of level ground in between a mound and a pit. And before we dig, there's always some useful tools to have with us. Firstly, you'll see that I have a long-handled round nose shovel. This is ideal for digging soil pits. It allows us to dig nice big soil pits with relative ease, and we can get nice and deep. Second, we want a ruler for measuring our forest floor horizons and our soil mineral horizons. Thirdly, we have a hand trowel. When we get deep down, it's easy to get out, dig around rocks, dig around or through compacted horizons with a hand trowel. We have a set of short clippers, small handheld clippers, and then we have longer handheld clippers for any small, medium-sized roots that we do have to cut through. So whenever digging a soil pit, these are ideal tools that I recommend you have on you. So with that said, we are going to start by digging a soil pit. Soil pits should be dug with a diameter of about 2 to 3 feet. The reason being is when we dig deep down, we don't keep straight edges. They get narrower and narrower and narrower as we dig down. So if you dig too narrow at the start, you're going to have a very shallow pit. And people always ask, well, how deep do we dig? Well, we dig as deep as we possibly can. So to begin, I've located this area. It's relatively clear of any surface stones and rocks on the surface. We are away from the dominant trees, so we should be able to dig a nice deep pit. You want to have your shovel straight when you first dig. So the idea here is we want to create an outline, and we do this by standing on our shovel, jump down, give it a pry, go right beside it. Same idea. You will hit rocks, you will hit roots, and whatever else you find in the pit. Sometimes you won't be able to get in the ground at all. This one sounds like it's going to be a lovely pit full of rocks. So we've made it all the way around. We give it a few pries, loosen up the forest floor and the topsoil as best as we can. What I'm going to do, this top layer, if we can get it out, it's called a cookie. So the cookie covers our forest floor and it'll have a bit of mineral soil attached to it. I'm going to cut this cookie in half so we can take out part of it so we can analyze it. When digging soil pits or completing any part in soils, I highly recommend you have proper footwear and clothing. Don't show up in high heels or sandals. You should have steel toe boots and good work clothes. So this is our cookie. We have our forest floor with a bit of mineral soil on the bottom. And what we're going to do is everything we take out of the pit, we want to put it beside the pit and at a higher elevation, so it's easier to refill our pit when we're done. Gotta love that sound. Alright, so we have our pit dug, and a few things I want to go over with you is why I recommend digging a wide soil pit. As you can see here, we've come across this nice large stone, and this stone goes all the way down to the bottom of the pit and deeper. So our pit is roughly 18 inches deep, and this stone continues to go down, so there's no way we're getting that out. This is why I always recommend digging a wide pit. So when you come across an obstruction such as this, you just dig to the side, no questions asked, no issues, you keep digging down. And you can see some of the stones that we've been pulling out of our pit. So one thing you notice about these, or a few things we notice, A, they all vary in size. This is very important because this helps verify that we're dealing with an ablation till. The other thing that helps us verify we're dealing with an ablation till is how rounded these rocks are. All the edges are broken off and everything's been rounded. So what this tells us is the glacier was just grinding them and rounding them as the glacier was growing and moving. And then as it's receding, all of these rocks just fall out of the glacier onto the ground and the mineral soil forms around it. So we get rocks of all different sizes and they're all rounded. So we know we're dealing with an ablation till. And you can see also that we come across a lot of roots in our digging. These roots either have to be cut or worked around. So this one, unfortunately, we had to cut. It was connected to here. Other than that, there's no large roots that were in the way, so the trees should be fine. Once we have our pit relatively dug, what we want to do next is we want to clean out our pit and keep it nice and clean so we can identify our mineral horizons. And we do that by just scraping out all the loose stuff that falls in the pit. More rocks, some forest floor, and one of the best ways to do this, once you get the majority of the material out, just use your hands. You get more rocks. The reason we do this is we want to clearly see the bottom horizon, the one we're digging through all the way at the end. And what we're going to do is we're going to use this profile here to identify our mineral soil. Another thing you want to do, starting at the top, because gravity is going to push everything downwards, we want to use our hand or our trowel, and we simply want to just scrape it from left to right. What this does is it gets rid of all the loose mineral soil that's fallen in the pit, so we can more easily see our horizons. So, once we've done this, we want to clear a spot beside our pit. And by clearing, I just mean remove the majority of the loose material that makes up the forest floor. And what we're going to do, starting at the bottom of the pit, working our way up every 5-10 centimeters, we're going to take a sample and lay it out here to rebuild the profile, but so we have all of the natural light so we can actually see the profile itself. So we start at the bottom, all the way at the bottom. I'm not sure if you can see these, all the way at the bottom of our pit we still have roots, which is a good sign, which means we're dealing just with an ablation till. There's no basal till material here. So this is the bottom. We have a sample. For now, we'll take a stick, we'll lay it on top of it. So put your hand underneath and catch the material that falls out from on top. So as you're scraping, we just catch the loose material, we lay it out. We come up just above that, complete the same process. Come up above that a few centimeters, we do the same thing. This is the same one that I just took out. I'm just getting more sample. You want to make sure, if you see any color change, make sure you capture that color change. When you're taking your samples, always take your samples on top of one another because of the thing known as translocation, which means materials, minerals, nutrients will move vertically with gravity. Therefore, we want to take all of our samples in a straight up and down line. The other issue is if you have mountain pit microtopography, you're going to have what's called broken boundaries. And what that means is your horizon profile on one side of your pit may be different than what you see on the other side of the pit because of trees uprooting and falling over. So always work on the dominant side. So you look at your entire profile, you say, okay, this is the dominant profile. We're going to use this profile for identifying our mineral soils. Once we have, we'll throw the cookie up on top. So actually we'll start with the cookie. This is what I call the cookie. This is our forest floor with some mineral soil attached. And what we want to do is we want to identify our forest floor horizons. So we start with our litter. Our litter is any freshly fallen material that lands on top. So we have some needles, mainly needles. There's a few leaves that are decomposed. This is our litter, anything that just falls from the vegetation and lands on the surface. As this begins to decompose, it goes through a phase known as fermentation. Fermentation means that it's being decomposed by bacteria, microorganisms, fungi, insects, just weathering over time. With this, the litter is still recognizable. We can make out what makes it up, but we know it's being decomposed, or we know it's going through decomposition. So this is our fermentation horizon. Here's more of it. You can tell it's quite decomposed, but you can still make out what it's comprised of. And sometimes, but not all the time, you'll find what's known as humification or a humus layer. Humus layer is a result of decomposition without biomixing. So I'm just coming over here because there's some humus. So what that means is microorganisms, bacteria, fungus will mix all of the nutrients and the organic material into the mineral soil. If they're not present, the organics accumulate in the forest floor. And when they become fully decomposed, it's called humus. And it's this black, dark, greasy material that if you rub between your thumb and your finger, it'll stain it. It feels like oil. That's humus. So again, it's not in this profile, but I just wanted to introduce it to you. And now below that, we get right into our mineral horizons. So we ask ourselves, well, this is the bottom of the forest floor. We have litter, our fermented horizon. And then we're into mineral soil. So we ask ourselves, of our mineral soil, is this the same or different than that? And you can see that there's some darker material in here. That is that humus being mixed into our A horizon. So therefore we say, well, these are separate entities. This is one horizon, this is another. So these are our A horizons. So they're the first mineral horizon that we encounter in our profile. And we see that this A, the dominant color in here is white. This white means eluviation. Nutrients are being leached out due to precipitation and acidity. So therefore, we call this an AE horizon. With that, we see that there's some organics in there, so we simply call this an AEH horizon because the dominant process is the eluviation, that white, but there's some organics in there. Below our AEH, we have simply our AE horizon. I've accidentally mixed some B in there, that's why we have some of that orangey color. Just disregard that. So here's a true AE, that pure white. That's what an AE horizon looks like. Below our AE horizon, we come into this orangey material. This is our first B horizon. With that, our B horizon, we can tell based on the color there's a lot of iron in it. Think of rust. Because of that, we call this a BF horizon. When we have eluviation occurring in our A, we're going to have illuviation with an I going into our B horizon. Think of emigration, immigration, or exiting going into. It's exiting, emigrating from here, going into here. So our nutrients, our iron, is being leached out of here, and it's going into here, giving it this orangey color. Below our BF horizon, now these ones are a bit trickier because they all look quite similar. We have this material. So we ask ourselves, is this the same or different than this? And the easiest way to determine horizons is clearly by color. So we look at it and we say, well, is it the same or is it different? And if you can't tell by color, look at the dominant process or the dominant physical properties. Rub it between your thumb and your finger. Feel for coarse fragments. Feel the texture. Look at the structure of it. Based on this, there's a slight difference, so I'm going to put my stick there, and then we simply do the same process all the way down. Is this the same or different than this? So I do notice that we're already getting into the smaller coarse fragments. There tends to be a bit more clay in here, as is with this one. So I'm going to say these are the same, and we simply just move it up. Then we do the same thing. Is this the same or different than this? I'd say again that is the same based on the coarse fragments and the texture. So this is the profile we have. We go from our litter, fermentation, our AEH horizon, AE, BF, and then this would be our BC because it's a transition from our B horizon into the C horizon. The reason I know this is a C horizon, A, it's at the bottom of the pit. B, we start getting a lot of smaller, rounded, coarse fragments, and it tends to have a bit more clay in it. So we call this a C. So again, L, F, AEH, AE, our BF, BC, and C horizon. If this was compact or cemented, we assign different subscripts, but where it's easy to dig through, we just call it a C. Once we have them laid out, what we want to do is we want to see where these are in our profile, and we want to measure the depths and record our depths. And we record our depths on the third page of your lab handout. So, the top, we start with our organic horizons. We measure our L, our F, and our H if present. We provide the depths. We describe the roots in the description. So I find it's always easiest when you're doing the depths, start at the top. So we look at our L, we say, okay, well there's a very little L. It's maybe a centimeter. So we record our L as 1 centimeter. We look at our F horizon. Our F horizon tends to be a bit thicker. So we call that about 3 centimeters for our F. Our AEH. So it'll probably be difficult for you to see here. Our AEH is about 2 centimeters, followed by our AE. Again, we want to clean it up so we can see the boundaries or the transitions. Our AE is about 4 centimeters. So we record the 4 centimeters for our AE. And we continue to work our way all the way down. And just continue to clean up your boundaries so you can see them. And another good thing to do, and it's especially if you're new to this, is wherever your boundaries are, put a stick so you know where they are. Some people use golf tees. I colored golf tees, those work quite well as well. So once we enter our BF horizon, it goes to about here. So we're looking about 6 centimeters for our BF. And again, it can be difficult to see where the color change is in your horizons. That's why I always recommend laying them out so we get some natural light on it to see the differences. Below our BF, we have our BC. It goes to about here. We're looking at about 7 centimeters. And then we know from BC all the way down, it's just our C horizon. So we record our horizon depths. And that is, so this is in a nutshell how we dig a soil profile, how we locate where our soil profile is going to be. We dig it, we keep it nice and wide, go as deep down as we can. We identify our forest floor horizons. We identify our soil mineral horizons. Identify our coarse fragments, which are the rocks. Another thing I'd like to mention is when you're looking at a soil pit and you're identifying your vegetation species on page 1, I highly recommend you look at least a 5-meter radius around your pit for identifying vegetation. The reason being is all the leaves, the needles, the nutrient uptake from roots are all going to affect this mineral soil within a couple meter radius. So you want to identify all of the dominant overstory, your canopy, your understory, your ground veg, shrubs, whatever there may be within probably a 3 to 5 meter radius of this pit. And you identify those species on page 1. And that is all for the video number 2, the instructional video on how to dig a soil pit and analyze our mineral horizons. Thank you for watching, and we'll on to the next one.